Now, we'll take up one more concept, that is the relation between modulus of elasticity and bulk modulus. So here, consider a block of a cube, side A, subjected to stresses sigma in three mutually perpendicular directions of x, y, z, as shown in the figure. So that is, here you have a cube of equal dimension having the direction x, which is sigma, and y again acting in the direction sigma y, and the z acting in the direction z axis, again the normal stress, which is sigma. So then the stress sigma in the xx direction cause tensile strain. So what is that? Sigma by E in xx direction, and the compressive strain, that is equal to sigma by m into E in the direction of yy and zz direction. Here, how you get this compressive strain? That is because 1 by m, so epsilon lateral will be equal to 1 by m into epsilon longitudinal. That is 1 by m into sigma by E in the yy direction and in the zz direction. So this is what we have already explained all these things in our previous videos. You can refer that. So what is epsilon x? Epsilon x will be equal to sigma by E minus sigma by m into E minus sigma by m into E, because along the direction of xx will be tensile strain, and along the direction of yy and zz direction will be compressive strain. Therefore, it will going to be negative. So when you are considering this sigma by E into 1 minus 2 by m, similarly epsilon y will be equal to sigma by E into 1 minus 2 by m, and epsilon z will be equal to again sigma by E into 1 minus 2 by m. So what is the volumetric strain? The volumetric strain epsilon v will be equal to epsilon x plus epsilon y plus epsilon z. So you have substitute these values, that is 3 sigma by E into 1 minus 2 by m. So by definition, what is the bulk modulus? K will be equal to the direct stress sigma by volumetric strain epsilon v. So K will be equal to stress is sigma divided by volumetric strain, which is 3 sigma by E into 1 minus 2 by m. So sigma gets cancels. So therefore, K will be equal to E by 3 into 1 minus 2 by m. So what is Young's modulus? So the relation between Young's modulus and the bulk modulus will be equal to E is equal to 3K into 1 minus 2 by m. Or what is K? K will be equal to E by 3 into 1 minus 2 by m. So by taking the LCM, 3 into m minus 2 by m, take that m to the numerator, it will be m into E by 3 into m minus 2. So where E is the modulus of elasticity and K is the bulk modulus and 1 by m is the Poisson's ratio. So similarly, we will going to establish a relationship between the modulus of elasticity and modulus of rigidity. So what is that? When we are applying a member which is ABCD is subjected to shear stress, which is the complementary shear stresses, and here consider a square element of ABCD of sides A subjected to pure shear, which is tau, as shown in the figure. In the figure, A, B, C dash, D dash shown in the deformed shape due to shear tau. So that is what we have shown here. When the tau is applied, so since this tau is also applied here, so this is fixed. So C will going to be displaced to C dash and D is going to be displaced to D dash. So naturally, you will going to get this elongation. So this is how, and this is the strain, which is going to be phi, the angle subtended. So that is what here, what due to shear. Draw DE perpendicular to BD. So here we say draw DE perpendicular to BD dash. So then this is the construction, what we do. Then let phi will going to be the shear strain. That phi angle is the shear strain. What we are talking about, this phi is the shear strain. Similarly, here also this phi will going to be the shear strain. Now tau is the shear stress and C or G is the modulus of rigidity. What is the strain in the diagonal BD? So that is BD dash minus BE by BE. So what is that? Strain in the diagonal BD is the strain in the diagonal BD will be equal to BD dash by BD. Since we have drawn the perpendicular here, BD will be equal to BE. So that is what we will going to substitute there. BD dash is nothing but ED dash by BE. What is ED dash by BE is nothing but BD. So therefore, BE is equal to BD. So as the deformation is small, so take DD dash E will be equal to 45 degrees. So what does it mean here? In this figure, you will going to get it as DD dash E will be equal to, so this angle is talking about, it is 45 degree. So therefore, what is cos 45? So cos 45 is nothing but adjacent side, opposite side by hypotenuse. So D dash E by DD dash, opposite side is, so since the angle subtended is here, so opposite side by hypotenuse the sine, adjacent side by hypotenuse. So that is the angle D dash E by hypotenuse is DD dash. So the angle subtended here is on this angle, which is 45 degree. So to this opposite side is this and the adjacent side is this. But what I want is opposite side by adjacent side by hypotenuse, that is adjacent side is this, that is D dash E by hypotenuse is DD dash. So therefore cos 45 degree will be equal to DD dash by DE dash by DD dash. So therefore D dash E will be equal to cos 45, that is equal, D dash E will be equal to DD dash into cos 45. So cos 45, that is DD dash will be 1 by root 2 into DD dash. So strain in the diagonal BD will be equal to, so what is that? You substitute the value of D dash E as 1 by root 2 into DD dash divided by BD. What is DD dash by BD? So here from the square ABCD, BD will be equal to square root of A square plus A square, which will be equal to square root of 2A square, which is root 2 into A, that is root 2 into AB. So AB is equal to AD, so root 2 into AD. Therefore, as AB is equal to BC is equal to CD is equal to DA, which is equal to A, because it is a square cross section. Therefore, strain in the diagonal BD will be equal to 1 by root 2 into DD dash by what is BD? BD is root 2 AD. So you know that 1 by root 2 becomes half. So half into DD dash by AD. What is DD dash by AD? DD dash by AD is nothing but tan phi. So where you will going to get that? DD dash by AD, which is tan phi, which is opposite side by the adjacent side. So therefore, which is equal to tan phi. So since tan phi is small, so what we can say is tan phi will be equal to phi. So half into phi by 2, half into phi, which is equal to phi by 2, or which is equal to half into what is phi? Tau by c, because shear strain is shear stress by shear strain is c, which is equal to tau by phi. So once you get that, c will be equal to, strain in the diagonal BD will be equal to half into tau by c, half into tau by c. Therefore, the state of simple shear stress or shear produces tensile and compressive stress along the diagonals, and the values of each gyro stress is numerically equal to tau. So this is how phi by 2. So once you get that, strain in the tau by c, so c is equal to tau by phi. So equal to tau. Shear stress by shear strain is the modulus. So this is how you will be able to, hence the linear strain epsilon in the diagonal BD due to two mutually perpendicular directions are given by epsilon will be equal to sigma by E minus sigma by m into E on the two-dimensional plane. It is not, we are talking about 3 dimension. So epsilon z will be equal to 0. So sigma by E minus sigma by m into E. So sigma by E plus sigma by m into E. So that is equal to, you know that sigma is equal to tau, which is already proved. That is equal to tau by E plus tau by m into E. That is sigma is equal to tau. Therefore, epsilon will be equal to tau by E into 1 plus 1 by m. So what is epsilon? Half into tau by C will be equal to tau by E into 1 plus 1 by m. Tau gets cancels. Therefore, E is equal to 2C into 1 plus 1 by m. So this is the relationship between the modulus of elasticity and modulus of rigidity. Or we can say C is equal to E by 2 into 1 plus m. So that will be equal to, taking the LCM, m into E by 2 into m plus 1. 2 into m plus 1. So this is how you will be able to get this relationship. Now we will going to establish a relationship between Young's modulus, modulus of rigidity, and bulk modulus. So E is the Young's modulus, C is modulus of rigidity, and K is the bulk modulus. So we know the relationship between Young's modulus and modulus of rigidity, E is equal to 2G or 2C into 1 plus 1 by m, and relation between Young's modulus and bulk modulus, E is equal to 3K into 1 minus 2 by m. So as the Young's modulus is same on both on the left hand side and the right hand side, E. So 2G, what is 1 by m? 1 by m will be equal to, so if you are considering that E by 2G into E by 2G minus 1, so that is minus 1. So once you will be getting that. So taking the LCM and E minus 2G by 2G, so E is equal to 3K into 1 minus 2 into, substitute the value of 1 by m as E minus 2G into 2G, E minus 2G by 2G. So you just take the LCM and simplify on cross multiplications. E is equal to 3K into 2G minus 2E plus 4G by 2G. So on simplification, is going to get 3K into, here 4G plus 2G, here 4G plus 2G will be equal to 6G minus 2E by 2G. So you take, so once you can cancel the 2, so you are going to get finally 3K into 3G minus E by G. So that will be equal to 9kg minus 3ke by G, which is equal to E. Therefore, E into G will be equal to 9kg minus 3ke. So then what we're going to get, Eg plus 3ke is equal to 9kg. So that means you are taking the 3ke to the left hand side. So now what happens, E is the common factor, E is equal to E into G plus 3k is equal to 9kg. So therefore, E will be equal to 9kg by G plus 3k. So this is how you will be able to establish the relationship. Similarly, E is equal to 2G into 1 plus 1 by m, which is equal to 3k into 1 minus 2 by m. So equating these two Young's modulus, which will be equal to 2G plus 2G by m is equal to 3k minus 6k by m. So taking this left hand side, ck by m on the left hand side, 2g by m plus 6k by m will be equal to 3k minus 2g. So 1 by m into 2g plus 6k, taking the common factor 1 by m here, which is into 2g plus 6k will be equal to 3k minus 2g. Therefore, 1 by m will be equal to 3k minus 2g by 2g plus 6k. So this is how you will be able to establish the relation between modulus of Young's modulus, modulus of rigidity, and bulk modulus. Thank you.